Dear students, we all know what is matter. Matter is the substance or object that occupy space and can be weighed. That means matter has volume and a mass. So this is called matter. There are different entities of matter such as atoms, molecules, ions, and sometimes in terms of electrons and protons can we also describe the amount of substance present in a given matter. We always come across this type of object measurements such as 1 dozen banana or 1 dozen matchbox or 1 dozen agarbatti, like that. So we know that 1 dozen is equal to 12 number of objects or 12 number of entities in a package. So 1 dozen banana is equal to 12 numbers of bananas. 1 dozen matchbox give us idea that there are 12 number of matchbox in a package. Similarly, 12 number of packets of agarbatti is called 1 dozen agarbatti. So similarly, in chemistry, the amount of substance which is a fundamental quantity, so that fundamental quantity has some units, and the SI unit of the amount of substance present in an object is called 1 mole. Mole actually, MOLE, mole. So SI unit of amount of substance is mole. Now, what is mole? How we can define a mole? So let us consider a carbon isotope. Carbon isotope which has mass 12 gram. Okay, so we called it as 12 gram or 12 gram of C12 isotope. So from the experiment, it is calculated that the number of atoms present in 12 gram of isotope of carbon 12 is equal to 6.022 into 10 to the power 23 number of atoms. It is found that 12 gram of carbon 12 isotope has 6.022 into 10 to the power 23 number of carbon atoms in it. This number is called Avogadro's number. Avogadro's number. So, the amount of substance which has 6.022 into 10 to the power 23 number of atoms is called 1 mole of carbon 12 isotope. The amount of substance which contain 6.022 into 10 to the power 23 number of carbon 12 isotope atoms is called 1 mole of substance. Therefore, it can be written as 1 mole. 1 mole is equal to 6.022 into 10 to the power 23 number of carbon 12 atoms. So whenever we say 1 mole substance, that means that substance contain this number of atoms or molecules or ions in it. Therefore, 1 mole of water molecules is always equal to 6.022 into 10 to the power 23 number of atoms of water molecule. Number of this much number of water molecules. It is water molecule, therefore it should be molecule. Okay. If the substance is in molecular form, then the Avogadro's number will be in molecules. If the substance in atomic form, then number of entities of is equal to 6.022 into 10 to the power 23 number of atoms. Or if the substance is in ionic form, then the 1 mole ionic substance is 6.022 into 10 to the power 23 number of ions. Also, 1 mole of sodium chloride is equal to 6.022 into 10 to the power 23 molecules. Thus, every atoms or molecules or ions, basically electrons and protons, they have their own mass. Thus, 1 mole of substance contain this much number of entities, and all these entities give some mass. So, mass of 1 mole of a substance in gram is called its molar mass. Molar mass can be calculated by using its molecular formula and the definite mass associated with the number of molecules present in it. Let us find out the molar mass of water molecule. Water molecule has 2 number of hydrogen atom and 1 number of oxygen atom. So hydrogen atom is equal to 1 gram. So multiplied by 2 plus 16 gram for oxygen atom. Therefore, molar mass of water molecule is equal to 18 gram per mole. Similarly, for oxygen molecule, molar mass can be calculated by multiplying 2 into 16. 16 gram is for 1 oxygen atom. There are 2 oxygen atom in a molecule, so multiplied by 2 it gives 32. Similarly, we can calculate molar mass for any compound. We have considered here it is sodium chloride, common salt. So molar mass of sodium chloride is equal to 23 gram per mole for sodium atom and 35.5 gram per mole for chlorine atom. So total we have 58.5 gram per mole molar mass of sodium chloride. In order to calculate moles, there are different possible conditions to find out moles. For example, the first one is when weight of a substance is given and we have to find out the number of moles in it. What is the number of moles of substance present in a given weight of substance? In that case, we will write the ratio given weight by the molar mass of the given substance. This gives us number of mole. For example, 5 gram of hydrogen is given. 5 gram of hydrogen is given. We have to find out the number of moles in 5 gram of hydrogen. So hydrogen gas always exists in molecular form. So to find out the number of moles of hydrogen gas, we have to divide 5 gram divided by 2. That means atomic mass of hydrogen is 1. Hydrogen always exists in molecular form, that is H2. So 2 multiplied by 1 give us 2. So 5 divided by 2 give us the number of moles. In order to calculate moles, there are different possible conditions to find out moles. For example, the first one is when weight of a substance is given and we have to find out the number of moles in it. What is the number of moles of substance present in a given weight of substance? In that case, we will write the ratio given weight by the molar mass of the given substance. This gives us number of mole. For example, 5 gram of hydrogen is given. 5 gram of hydrogen is given. We have to find out the number of moles in 5 gram of hydrogen. So hydrogen gas always exists in molecular form. So to find out the number of moles of hydrogen gas, we have to divide 5 gram divided by 2. That means atomic mass of hydrogen is 1. Hydrogen always exists in molecular form, that is H2. So 2 multiplied by 1 give us 2. So 5 divided by 2 give us the number of moles. So number of moles can't be in. When number of particles of a particular substance is given and we are asked to find out the number of moles, then we will use this ratio. Given particles, that means given number of particles divided by Avogadro's number. This ratio gives us the number of moles. Similarly, for a gaseous substance, if the volume of a gas at a standard temperature and pressure is given and we are asked to find out the number of moles, then we have to divide the given volume of a gas by 22.4 liter of the gaseous substance. So this will give us the number of moles. This formula is valid only for gaseous substance, and the necessary condition is the temperature and pressure must be in standard form or normal temperature and pressure should be exist. Once we know the concept of moles, then we can easily understand the concentration of a solution or amount of substance present in a given volume. We can easily find out the concentration of a solution in terms of mass percent, in terms of mole fraction, in terms of molarity, and in terms of molality also. So amount of substance is always dependent on the number of particles present in the given solution or volume. So mass percentage is the expression of mass in terms of percentage. Then mole fraction is the number of moles of solute and solvent present in a solution. Molarity is the concept of number of moles present in volume of solution in liters, and molality is the number of moles of solutes present in the mass solvent in kg.